Okay, if you're looking at the board, are you looking at the board right now?
Yeah.
This is page 131, Congruency lesson number 4. It's ASA Congruency Postulate. So the first thing you need to know when it comes to congruency is, what is congruency to you? If two triangles are congruent, what are we saying about the two triangles? They're the same. Everybody say congruent.
Congruent.
And then say same.
Same.
Now, why do you need a new word? Isn't congruency a new word for most of you? You're like, what's the other word you might have said other than congruency before this? Same is good. Give me another math word. If two triangles are the same in math, you would say, I'm hearing identical is good, but I'm looking for equal. Why not just say the two triangles are equal? Good. And I understand why you're saying this. Why not just say the two triangles are equal? Why not? Why do you need a new word, congruency? Why? Why? Why do you need a new word? Okay, so let me walk you through it. Here's my perspective.
Let me see your grade.
Nathan, I love it if you and Leo I feel like I just start something and you are too. Let me ask you this. If you have the number 5 and you put the other 5 next to it and you say 5 equals 5, this makes sense to your brain, right? 5 equals 5. That's one aspect of equality. And so we use the word equals. Now look at the triangles. Look at these two here. See the two triangles?
Yeah.
Are they equal to each other? Now you've got to ask, is this angle exactly the same as its matching angle or corresponding angle over here? Is this angle equal to its corresponding angle? Is this one equal to its corresponding angle? Is the length of this side equal to the length of its corresponding side? Is the length of this side equal to the length of its corresponding side? Is the length of this side equal to its corresponding side? You see all the different equalities we're talking about now. Maybe 6 aspects of equality you're asking. Does this make sense? You see how it's different from 5 equals 5 at least? 5 equals 5 is just one equality. Now you're asking, are the 3 angles of this one equal to the 3 angles of that one, and the 3 lengths of the sides equal to the 3 lengths of the corresponding sides of that one? Do you see how it's more aspects of equality? Kinda? Okay. Hence the new word congruent. You with me? Hence the need for a new word. Is this okay? Does this make sense? I don't really see your eyes going, it makes sense. But congruency is now multiple aspects of equality. Not just one, but many. The angles and the sides, you're asking. Okay with this? Okay, hang on one second. So, ASA congruency postulate. What's a postulate versus a theorem?
A theory?
A theorem. So, here's the difference. Postulate is a definition, like how many degrees are in a circle? 360. That's a definition. We made it up. You with me? We defined it. A theorem now uses that 360, the postulate, to prove itself, right? So you could use something about circles and you could prove something that could become a theorem now. Okay, so that's all of this is in your school G's when you take this. Hopefully it sounds familiar and you're practicing those. So here's what it is. Given two triangles with two corresponding equal angles and equal included sides, what can be said about the two triangles? They're going to be congruent. So look at these two triangles. Let's just go right off the bat and practice it. Do these two triangles look an equal size to you in shape? This one and this one. Do they look congruent to you? No. Why? Because they are not drawn to scale. Everybody say not drawn to scale. You can leave it there. Everybody say not drawn to scale. Okay. Pretend, here's the two triangles. They're exactly the same. They're congruent. Now take one and move it close to you, and it's going to be bigger. It's going to be bigger, right? Move this one away from you, it's going to be smaller. Even though they're exactly the same size, pretend they're at different distances. Now one looks bigger, one looks smaller. Why do we want them drawn different sizes? Because we want you to use the ASA angle side angle congruency postulate to prove congruency, not just look at them and say, oh, they're the same size. Are you okay with this? Okay, so the triangles are not going to look the same size, but they may actually be equal or congruent. Okay, are you okay with this? I don't know if your eyes, if you're telling,
Yes.
I don't know if you're acknowledging this or not. Okay, so look at this one. See the first triangle? See the one tick mark. It's an equal size in angle measure to this one here, D. Look at the next one. 2 tick marks match up with this one. So this one and this one are equal in corresponding locations to this one and this one, right? Look between them. The length of the side is the same length as the side between them. You with me? This is now an angle, side, angle, and it matches up with an angle, side, angle. Are you following me? Are you following? Are you following? Okay. That's all it is. And then notice the symbol between the two. Somebody read this to me. What's this say?
Triangle.
Triangle ABC. And notice the symbol is an equal sign plus a squiggly over it. That's the congruency symbol now. So I like to think of it as it's not just equal in one aspect, it's equal in all its aspects. The angles that correspond to each other are equal. The side lengths that correspond to their side lengths are equal also. So it's not just equal, it's even more than equal, right? It's congruent. You okay with this? So triangle ABC is congruent to triangle DEF. You need a reason. In this case, it would be angle, side, angle, right? Here's one more, but now they're dropping in dimensions on the angle measurement. So here's a 42 degrees matching up with a 42, 110 degrees matching up with 110. The length of the side included between the two angles is the same, 7 and 7. So what does included mean? See how there's two angles and the side length is here. It's included between those two. This one also, it's, in other words, it's not angle, angle, and then the side over here. It's angle, side, angle in that order, and this one goes in the same order too. Does that make sense? So hence the word included side is between those two angles on the triangle. Is this okay? Okay, so this is number 4. You have to 4 postulates or definitions of how to determine that two triangles are congruent or equal. Pretty simple. Okay, so you're making sure to take notes on page 131. Then you're going to switch to School G's now and do those. So are you at a stopping place on your notes? Okay, stop your notes right now and switch over to School G and do the assignments for these. Ready, set, go. Okay, Melanie, will you stop that? Thank you.